2.6 is about the distributive property. We're going to first show you an example using an area model. In the first rectangle here, I'm going to pretend that I'm going to find the area of two separate rectangles. So I'm going to first find the area of this rectangle. If this side here is 3, that means this side over here is also 3. So the area of this first rectangle is going to be 3 times x, length times width. And we're going to combine that with the area of the smaller part of the rectangle, which could be 3 times 2. And we will have an example of area there. Now, I can also do the same thing, showing you distributive property. I can do 3 for my width, we'll say, and then my long side here is x plus 2. Now when I distribute, and that means this 3 is shared by both the x and the 2, that would give me 3x plus 6. If I combine my terms here, I get 3 times x is 3x plus 3 times 2 is 6. So you can see the distributive property using one common term. I can write it in this simpler form. Sorry. Okay. Sorry, I shrunk that too far to turn the page. So using the distributive property, you noticed that I used my little arrows here. I'm doing that just as demonstration. If this helps you, you certainly may use it, but I would recommend that you start to learn to do it without putting the arrows there, because as we get to more complex sentences, you don't need extra writing in there. So my distributor, if you want to call it that, is 2. I'm going to do my 2 times x plus my 2 times 5. Now I'm going to put a little box around this. In simple ones like this, I do not expect you to write that step. I would say that it's fine just to distribute that. So 2 times x would be 2x, and 2 times a positive 5 is going to be a positive 10. So you can skip the step that I have in white. I'm just over exaggerating so you see the process. In the next one, they try to trick you because they have the distributor at the end of the sentence. Now, if that bothers you, you can simply rewrite it, put the distributor out there, and then just recopy what is in the parentheses, if that makes it easier for you. Otherwise, you're just working from right to left. So now we have x times x. Now remember, when we're multiplying, that would give us an x squared. Of course, my 2 is not going to work. Oh, that was pretty good. And then I do my x times a negative 4. Make sure you pay attention to that integer sign. X times negative 4 is going to be a negative 4x. And that time I just skipped right to that step. So here's my final answer. Here was my final answer. We'll do a couple more of them. Again, I have this at the end. I'm going to just go ahead and do it this time. I have my 8 times 1. That's going to be 8. And 8 times a positive 2x, which is going to give me 16x. Now again, yes, proper form would be that you always put your variable first. But when you're doing that, remember to pay attention to your signs. Your 16x is positive, and your 8, there's no sign there, so that's an implied positive. So make sure that you keep your signs when you change the order. In the next one, they have it written correctly for the outside, but the inside again is in a slightly different order. So I would do my y times a positive 1 would give me 1y. So anything times 1 gives you the same thing. So there's my y. And then y times a negative y. So I'm going to have a y squared, but a positive times a negative is going to be a negative. So I have a negative y squared. Now again, to be proper, we put things in order by their powers. So my y squared And remember, my y squared is a negative y squared. The proper way to write this would be that the y squared would show up before or be read before the y. Again, make sure that if you do this extra step, right now I'm not requiring it, but you will change into this, so the sooner you start practicing it, make sure you bring those integer signs with you. This one is a positive y because it's implied that that's positive. And we have a couple more of these to practice. Negative 3 times x would be a negative 3x. I'm going to redo that one. That one's pretty. Let's try again. Negative 3x. And a negative 3 times a positive 4, a negative and a positive, is going to give me a negative. A little bit backwards here. Negative 4 times y, negative 4y. Negative 4 times positive 5, negative 20. Oh my goodness, we have some more. Now this one is slightly different. You're going to notice here, let's do a yellow to call your attention to it. We have a negative sign outside the parentheses. The negative is going to be distributive, but that is the same as a negative 1. There's nothing implied in it, or that's implied there. Another way to think of this one is that negative sign could mean opposite. So you have opposite of everything inside the parentheses. I'm going to go ahead and I'm going to do the first one that I wrote out. Negative 1 times a positive 6 would be a negative 6. And a negative 1 times a negative 3x, negative times a negative, would be positive. And that would be a positive 3x. Now again, I'm going to rewrite that, keeping my sign. So the proper way to write that would be 3x minus 6. Now, if I do it with the opposite, let's try that one. The opposite of 6 is negative 6. The opposite of negative 3x is positive 3x. I'm going to come up with the same answer. Whichever way works better for you, thinking opposite or putting in that negative 1. Again, they're going to do a little reverse here for you. Negative 9x times an x. Positive and a negative is going to give me a negative. I have a 9, and then I would have x squared. Negative 9x times negative 1. So a negative times a negative is going to give me positive, and then it's going to give me that same value, positive 9x. So we're finally to goal 2 after doing many, many practices. It says, in a term that is a product of a number and a variable, the number is the coefficient of the variable. When you don't see a negative, when you just see negative, that is, in fact, standing for a negative 1. And then, so if they ask for the coefficient for this term here, that would be a negative 1. I talked about that on the last slide. And then the coefficient for y squared is 3y. Like terms are terms in expression that have the same variable raised, have to have the same variable, and it has to be raised to the same power. In the expression below, 5x and negative 3x are the like terms, but 5x and negative x squared are not like. The constant terms negative 4 and 2 are also like terms, so you can simplify. Let's put one of these in. We'll start out easy and then keep adding to it. 8x plus 3x. Notice we're adding this time. We're not multiplying. So you just have 8x's laying on the floor, and over here you have 3x's. So you put those together, you'll end up with, you're combining them for 11x. In the next one, and again, I kind of do a little labeling. I do one line for the first like terms, and I might do 2 lines for the next, or I might circle and square and triangle, some kind of code. So I had 2 in this one that were x squared. I have a 4x. Make sure, 4x squared, sorry. Make sure you're looking at your signs. And I have a negative x squared. So 4x, I could actually rewrite this and put my like terms together. Again, I don't expect you to do this, but if this makes it clearer for you, you can go ahead and do this. So I've used this one and this one. I was careful and I followed my sign, and then I have a positive 2. Now to simplify, I have like terms here, so 4x squared minus x squared would leave me with 3x squared, and then the constant term plus 2. We're going to combine some things together. First step here is I'm going to leave my 3 alone, and then I'm going to do some distributing. Negative 2 times a positive 4 gives me a negative 8, and negative 2, let's go ahead and kind of overemphasize these. Sorry, that was a little shaky. And then negative 2 times a positive x would give me a negative 2x. Now, that's my only term with x in it. I'm going to put that first, negative 2x, and then I'm going to combine my constants, 3 minus 8, or I could add the opposite, or I have different signs, so find the difference. The difference between 3 and 8 is 5, and the 8 is the larger, so it's a negative 5. That would be my final answer there, negative 2x minus 5. Moving to the, oh, I don't have another one. Let me see, I'll put a couple blank ones in here maybe. Actually, that is the end of example 5. Example 6 is talking about to simplify a function. It's simply the same concept. I can do a new page here. Let's go ahead and insert a new page. It's going to be white for us. And this one is in the book on page 102. And they're giving you a function about going to school. So I'm going to write it down for you so you can see what I'm talking about. It's telling me that distance equals 0.06 t. And that's going to be plus 0.5, and that's going to be multiplied by the quantity 45 minus t. Now you should be able to follow this a little easier when I read it. So that it takes you 45 minutes to get to school. You spend t minutes walking to the bus. So this is this part of the expression here. Okay. And the rest of the time riding the bus. You walk 0.06 miles. This is my miles. You walk 0.06 miles a minute, and the bus travels at 0.5 miles a minute. This is miles a minute as well. I think I might have said 0.6 and it was 0.06. So 0.06 of a mile a minute is what you walk, and the bus travels at 0.5 of a mile a minute. So now it's asking you the total distance you travel is given by the function d equals, and there's my equation, 0.06 t plus 0.5 times the quantity 45 minus t. And it's just going to ask us to simplify this function. So the first thing I'm going to do is apparently stay in green. There is no operation here for the 0.06, so I'm just going to copy that one down for right now. We have some distributing that needs to be done next. So my 0.5 times 45 would give me 22.5, and that's going to be positive because both of those terms are positive. And then my 0.5 times a negative t is going to give me a negative 0.5 t. Now I have some like terms. I have some t's. They're both raised to just the first power, so they can be combined. So 0.06 t minus 0.5t gives me, and again, that was a negative, so that gives me a negative 0.44t, and then I still have my positive 22.5. You'll notice your operational vocabulary will start to change. Instead of saying adding and subtract, you're going to start using your integer language of positive and negative. And that now concludes that lesson.